Hi everyone, I'm Ariane Japan, your MC for this session. Now, let's talk about something every Python developer faces. That moment when your code breaks, your screen fills with the red lines. Panic, right? Frustration, but not today because this next talk is about turning those weird error messages into powerful clues. Our speaker is the amazing Rahmat Akintola Oyewole, software engineer, DPG technical advisor at Mest Africa. She is here to share a beginner-friendly debugging toolkit that will help you read tracebacks without fear and harness exceptions, login, and debuggers like pro. Get ready to shift your mindset from errors are scary to errors are opportunities. Let's dive into So It Broke. Now what? Debugging Python 101 with Rahmat Akintola Oyewole.
Hi everyone, my name is Rahmat Akintola Oyewole. I would be taking you through my talk for today titled Debugging and Python 101. So basically it means it's mainly for beginners, and we would be discussing some of the steps that beginners might want to take as they debug through their code, or they when they face an error, what they are supposed to do, and what they can do, and some of the tips and tricks that I've also done as I work professionally. I'm just going to open up my slides now. Just give me a minute to pull that up. Thank you. So, right, let's get into my slide. A quick introduction about myself again. I am Rahmat Akintola Oyewole. I'm a DPG technical advisor and a software engineer. And when I'm not coding, you would find me reading web novels. So we'll start with a quick quote that says, "Debugging is like being detective in a crime movie where you are also the murderer," by Felipe Fortes. So we would be in this session, I would be taking you through practical techniques on how you can transform your approach to broken codes or errors when you get them, and then we'll be exploring debugging through three key phases: understanding, investigation, and prevention. So, what does debugging mean using these three key phases, right? The first thing is understanding. You want to make sure that you understand how your code runs, not what how you think you should run now, but you want to really understand what is going on under the hood. And then the next thing you want to do is you want to investigate, why is this particular code breaking at this specific point? What are the conditions leading to this failure? And what were your assumptions that were wrong? What were you thinking that I've done this, I've done that, that were actually wrong? And the last thing you want to do is you want to find ways to prevent that from happening, basically maybe by having like a better way of testing, writing tests for your code, and then to kind of like maybe not prevent totally, but kind of limit the future bugs that you might get, and then making sure that your the quality of your code is up to standard. So debugging is more than just fixing error. It's a systematic process of understanding what's happening when your code breaks. You want to investigate why it happened, and you want to implement solutions to prevent it in the future. A quick example I can give of that is sort of when you are sharing, let's say you're contributing to an open source solution, for example, an open source project, and then you encounter a bug whilst you're trying to work on a PR or work on an issue, and you want to raise an issue for that bug that you've encountered. Most times they would always ask you to kind of add steps to reproduce that bug, right? So that's a way of like that. For you to be able to add that step to reproducing it, you need to be able to actually understand how that code is running, and then for whoever would be attending to that issue, they would need to investigate why it's breaking at that point. So those steps in reproducing is kind of like it do falls into this circle of understanding and then investigating before they can start looking at ways on how to prevent it from happening again. So this slide is just like we'll be using this error here, a screenshot of like an integrity error from a null value in column product ID coming from the database about a failing row because it violates the not null constraint. Basically, we are um we are trying to save a null value where it shouldn't be a null value, that sort of thing. And then this is just a fun description of how Python 1 developer 0 when you're counting scores. And yeah, right. So let's debug this code. What are the practical ways that we can look into debugging this sort of error, right? So the first thing we want to do is we want to use our trusty print statement. It's one of the first thing that we would actually learn when starting to code. It's one of the first thing that you would actually learn when starting out to code. You use the print method, and it's simple, it's everywhere, it works really well for quick checks. So this is an example of a create add function here that takes in the product ID, the add type, and then the price. Looking at the error that we had where it says the null value from product ID, so we can assume that we are not passing in our product ID, that's why it's failing. But because we want to understand how this code is running, right, we are going to put a bunch of print statements here to kind of print out our variables for us. And then we have an if statement also that's checking if the product ID is none, it should print missing product ID, else it should print that it has been able to create successfully. The good thing about using this print statement is that you're able to get your immediate feedback. It requires zero setup since you can literally just use it, and then it works everywhere. Perfect for quick sanity checks and basically understanding the program flows. But then the bad thing is that too many of print statement turns your code base into a noisy mess. I mean, you can't push this your prints like all of these print statements into your production environment where you need to have like persistent records. So removing them you would actually spend more time removing them than debugging, but it works really well for understanding kind like your program flow. I do tend to use this a lot myself, but then I always have to like remove them after. Then the next thing is on the prevention part of things is you want to raise and undo exceptions, right? So this is where we kind of like level up our programs. Be already been able to understand and investigate where that error is coming from. Now we want to anticipate problem and then undo them gracefully. Instead of letting our code crash, we want to be able to signal that this is where something went wrong, this is where it went wrong, instead of just having like a random crash. So raise we can use the raise keyword here to kind of like signal problem explicitly instead of just having the error come implicitly, right? So basically we can choose our appropriate exception types, which can be like a value error for bad values, type error for wrong types, or you can even create your own custom exceptions for domain specific errors. Then you can undo them. So for handling exceptions, we can use the try except block to kind of catch and undo errors without crashing. So basically from this code block here, our create listing that does not have a product ID but as the add type and then the price, we are putting it in a try block that says that if this thing, try this code first, but then if you get an exception, like if you get any error, undo them in the except part, right? So you can print that error, or you can even log that error. So you are providing like some graceful, meaningful feedback for your user instead of like just cryptic traces and all of those things. So the next thing we want to look at is login. So another thing that you can use even beyond just print statements is you want to use your you want to use the built-in Python login module to kind of undo appropriate handlers. And then for when using login, you can choose different levels. We have the debug level for detailed information. We have the info for general event. If you want to share a warning, we have the warning for potential issues, and then errors for problems. And for login, you want to add them strategically in places that error conditions might come in, where data are being transformed or processed. So you don't want to put it all over the place, right? And the good thing about login is that you can push them to production, and because you can even use um those traces of your log to kind of like improve your code over time, right? And why does login matter? Unlike the print statement, logs can persist after deployment. You can filter by severity. You know, you have like the different levels. You can filter by timestamp, the context, and then you can even use them to set up like your monitoring systems in your production environment. So this code here is a sample of how login is being used for our create listing function. Another thing is we can also use assert. So basically, the assert is used in development. We don't push assert to production. So think of it as guardrails for your for your code, right? As you are working, as you are developing, you want to be able to test your assumptions, validate your assumption. Don't make them implicit. You want to make sure that you make all kind of assumption explicit in your code. You want to assert that, okay, if assert that an example of this is where we are checking if the product ID is not null. We want to check if our price is greater than 0. All of those things that you feel like maybe your user might not pass there, but you really might not know. So you want to like make sure that you kind of do like a quality control for all scenarios that you might want to think of. But we don't use assertions in production. If you get an error, it returns assertion error and then the message that you want to pass to your user. And then the last thing is we want to you another tool that you might want to use is actual debuggers. So instead of using things like the print statement where you have to write them one by one in your code or in your code base and all of those things, you can use the debugger. So we have the Python built-in debugger, then we have the ones that come with our IDEs as well. So for Python built-in debugger module, you can just import it using the import pdb, and then you put the pdb.setTrace. Wherever you put the pdb.setTrace from method in your code, execution stops there, and then it will take you into an interactive debugger where you can inspect your variables, you can step forward, you can step through. So this set trace is kind of like setting your breakpoint, right? And then you can step through like the code one by one, and then you can step forward using the N, you can continue using C. And another thing is also the debuggers that come with our IDs like VS Code, PyCharm, and Jupyter. So these debuggers kind of offer visual debuggers like that you can use on the IDE. You can use them for variable watches, and they are kind of like more intuitive than the Python debugger. So these ones are really perfect for complex debugging session. And then learn your ID debuggers. I'm actually still learning myself because I feel like it's a great way to kind of like debug compared to writing a lot of print statements. So just a quick recap on the toolkits that you can use for your debugging. We went through the print statement, we went through the raising and handling exceptions, we went through logging, how you can use logging and its different levels. We went through assertions and then the powerful tool which are debuggers and when you need to really dig deep into the code, step through execution and then see what exactly is happening. Just to round up quickly, a quick mindset shift. Errors are not scary, they are clues. Each bug in your code is trying to tell you something. And then with these tools in your toolkit, right, you are equipped to listen. The key thing is to practice regularly, try different techniques for different problems, see what works for you, and then remember every expert started exactly where you are now, staring at a broken program and wondering where to start. The difference is that they learn to approach debugging systematically instead of randomly. And now you can do that too. And now I can as well. Thank you very much, everyone. If you have any questions, you can put it in the chat and let's connect on LinkedIn and Mastodon.
What a fantastic session. Rama just showed us that debugging isn't about fixing mistakes. It's about understanding your code, building resilience, and gaining confidence as a developer. From print statements to logging, from assertions to Python building and IDE debuggers, she gave us practical tools to face errors head on. Remember, every bug is a breadcrumb leading you closer to mastery. So keep practicing, keep experimenting, and embrace debugging as part of your growth. A huge thank you, Rama, for empowering us to see errors not as setbacks, but as stepping stones. And thank you all for being part of PyLadies Con 2025.